Hey everyone, we're going to be talking about polynomials today. So polynomials are just like polygons. Polygons had many sides. Polynomials have many terms. So x plus 5, that's a polynomial. X squared minus 3x plus 100, that's a polynomial. So we're going to start by going over adding and subtracting polynomials first. So number one, it's basic adding like terms. So we know these two are like terms because they both have an x with the same variable. So 3x plus x would be 4x plus 5. You cannot add 4x and 5 because they don't both have the variable x. So I'm going to switch pens so you can see the problems versus the answers better. So number 2, we are adding these two, and when it comes to addition, it doesn't really matter if you have the parentheses or not. So this would just be a strict adding like terms. If you want to rewrite it without the parentheses, that's fine. So I have an x squared and an x squared. Those are like terms. So this is basically a negative 1 x squared and a 5x squared, which is 4x squared. I have a plus x and a plus 6. That 6 is positive. The negative goes with x squared. And I can't add any more, so that would be my answer. Okay, here's one with subtraction. Now this one, whenever there's a subtraction symbol, it makes a difference. So what we do here is this is basically a negative 1, and we are just going to distribute that negative 1 with everything in the parentheses. So this part stays the same because there's no negative 1 or anything in front of it. If there was a different number, we would multiply that out just like we're distributing here, but in this case there isn't. So negative 1 times 2x squared, negative 2x squared, negative 1 times negative 4x, positive 4x, negative 1 times 3, negative 3, add like terms. So I'm going to line these up because there are a lot of terms, so you could do it this way. So I have an x squared minus x plus 1. These are just my first ones. I'm going to line that up with the other x squared. This one with the x because it's positive, and then this one over here. So this one actually lined up pretty nicely. Sometimes they're all over the place, just depends. So x squared minus 2x squared is actually a negative 1x squared, or you could just write x squared. Negative x plus 4x is 3x. 1 minus 2 is negative, 1 minus 3 is negative 2. So that's our solution there. Let's talk about multiplying polynomials. So a lot of this has to do with how good you are with the distributive property. In this case, it's just straight out distributing. So 3x, 3 times x is 3x, 3 times 1 is 3. Okay, so you're just multiplying them. X times x, x squared. X times 5, positive 5x. If they're positive, you put a plus. If they're negative, you put a minus in front of them. Here's some more. These are a bit more complicated. I'm going to show you a couple ways to do them. So number 3, I'll show you one way, which is just using distributive property. So we start with the x, and we're going to multiply or distribute with everything in the second set of parentheses. So x times x, x squared. X times 7, 7x. Sometimes people call this FOIL, which is like first, inner, outer, last. It's the same thing as distributive property. So we took care of the x, now we're going to take care of that negative 1. So that negative 1 gets a turn. So negative 1 times x, negative 1x, negative 1 times 7, negative 7. Now we're adding like terms. So these two are the only ones we're adding. So x squared plus 6x minus 7. Number 4, anytime we have an x squared, it's just like x times x. So in this case, we would have x minus 4 times x minus 4. That's what x minus 4 squared means. So for this one, I'm going to show you a box method. And it's called the box method because you're making boxes. So it kind of looks like a multiplication table. We take the first term, we're going to put x here, and the minus 4 here. Same thing over here. They just happen to be the same, but depending on the problem, usually they're different. So these two went here. And now we're just multiplying like a multiplication table. X times x, x squared. Negative 4 times x, negative 4x. Negative 4 times x, negative 4x. Negative 4 times negative 4, plus 16. Pay attention to those signs. Okay, now we're adding like terms. So let me write them out here. All the terms that we got. So the middle two are the ones we're adding. So it's x squared minus 8x plus 16. Okay, let's get into GCF. Actually, before we get into GCF, let me just go over one thing with you. We just went over adding, subtracting, and multiplying polynomials. How do you know what to do whenever you see a problem? You look at the symbol in the middle. So whenever it's addition, you're just adding them. X plus x is 2x. X minus x, you have to distribute the negative. When it's distributed, you just do the problem. So x minus x would be 0. Multiplication, you have to actually just multiply. And usually there's no symbol, but if there is, it would be that dot in the middle. So x times x would be x squared. So just be aware you have to pay attention to the symbols. Now, GCF factoring is a little different. This is kind of backwards of the multiplying. So it's the opposite of distributive property. So if you remember GCF, greatest common factor. You might have done that in junior high. So we're looking at the biggest factor they have in common and we're pulling it out. So 6 and 12, what do they have in common? See, they have a 2, 3, and a 6 in common. We want the biggest one, so it's a 6. So I'm going to show you the factors. So 6 is 6 times 1. We also have that x. 12 is 6 times 2. We're going to take out the biggest, which would be the 6. And what's left over? 1x or x plus 2. In order to check your answer, you just use distributive property. So 6 times x, 6x, 6 times 2 is 12. So that's how you check your work. You use the distributive property. Number 2, I have a 2, 4, and a 10. Let's see, let me start with the smallest number. My factors of 2 are 2 and 1. 1 doesn't make a difference when factoring, so we're going to look at 2. Does 2 go into all of them? Yes, it does. So let's write the factors out. So 2 times 1, 2 times 2 for 4, and then 2 times 5. We also have a bunch of x's, so this is 3 x's, that's 2, and that's 1x. Let's circle everything in common. There's a 2 in common, and I'm only circling 1, 2, not both of them. Well, they all have x's, so I'm going to circle 1x, because this one only has 1x, so that's the most I can take from all of them. So in the front of my parentheses, I put what's in common, my GCF goes there, and then whatever's left goes in the parentheses. So I have x squared, or 1x squared, a positive 2x, and then a plus 5. And that would be my expression factored. Okay, we can distribute it to check. Number 3, again, what's in common? I have 8, 4, and 6. Let's start with the numbers. 4 is my smallest, so I'm going to look at my factors for 4. My factors for 4 are 1, 2, and 4. 2 goes into all of them. 4, because I want the greatest, let's see, 4 does not go into 6. So it would have to be 2. So I know this is going to be 2 times 4, 2 times 2, and 2 times 3. You want to pay attention to the negatives. So if this is negative, what would make this negative 4? One of those has to be negative, right? 2 times negative 2. Okay, and then my x's, I have 5 x's here, 2 here, none here. Circle the common factors. Looks like there's a 2 in common. This one has no x's, so I can't circle anything there. So my GCF is just a 2, and that's okay. Let's write what's left over. This is where that negative 2 comes into play. And a plus 3. Okay, let me know if you guys have any questions.